Here we want to look at distance, rate, time problems. And so I'm not even going to write down the full sentence, they say, because we can really sum it up with just kind of a picture and then always write down this table. You know, if you know how fast something's going and how long it's traveling, you multiply those two things to get distance. So I have two trains leave a station at the same time. So they're both starting here. One's going east, one's going west, it says in the problem. That whole sentence I can translate into, okay, I have two things going in opposite directions. One of them is going 95 miles an hour. And then the other one, it says, is going 105 miles per hour. How long will it take for them to be 560 miles apart? So we want to know, when do we hit the point where this distance from here to here is 560? Well, let's see what we don't know, what we know, what we can fill in. So anything that relates to one of the two trains, we have a westbound train and an eastbound train. Anything that relates to one of the two trains, we can put in the table. Now notice, be careful about the 560. I can't fill it in for distance because it's not the distance of just one of the trains, it's their combined distance, which is where the picture helps to see which part of it is each one, or if things are going towards each other or away from each other, or if they're catching up. The picture will tell you what you do with your distances in the end. All right, we do have two rates. We know the westbound one is 100 or 95 miles an hour, and the eastbound train is 105. So that's the rate or the speed. Now we don't know time for either one, but we're kind of in luck. We can use the same variable here because it says they leave at the same time. So an hour later, they've both been going for an hour. 2 hours later, they've both been going for 2 hours. What do I do with rate and time to get distance? I multiply them. So this is 95t and 105t. And I don't have to know what that number is, I just know that represents the distance of one train versus the other one. All right, so if I look at my picture, what do I do with my two distances? This distance plus this distance give me 560, or should give me 560. They're both pieces of one whole larger thing. And so if this represents the distance, one of these is going a distance of 95t and the other one's 105t, those two distances should add up to give me 560. And so notice that gives me an equation. Equals 560. So 95 and 105 adds up to 200. T equals 560. Divide both sides by 200, and so 560 divided by 200, and this is a real life problem, so we can put a decimal. We don't want a weird fraction number of hours, and so it looks like it's going to take 2.8, right? Remember, this is time, so since it's miles per hour, this is an hour, so it's going to take 2.8 hours until those are actually 560 miles apart.